Hi guys, welcome to another video here, grade 11 University Math with Mr. Lupos. Unit 1A, Day 7, CTS, Complete the Square. So the reason we do this is, I think I'll get into this first. The reason we complete the square is we have three different forms of a quadratic, and each of them gives us some information. So we start with standard form, and we have factored form, and we also have vertex form. And here's a basic quadratic represented by a parabola. And when we have something in factored form, we have our zeros. Our factors are our r's and our s's. So this is your r and your s, or your s and your r, also known as s and t sometimes. Anyway, there are zeros, and they are our x-intercepts or our roots, all the same sort of thing. And they are when the parabola hits the x-axis. And that's important because when you hit the x-axis, sometimes, most of the time, that's when it hits the ground. So you want to know when a parabola hits the ground in real life. Otherwise, you might have something in standard form, and that's y equals ax squared plus bx plus c form. And what the important part you get here is the c. And the c, if you remember, is the y-intercept. So the y-intercept here is when does it hit the y-axis. So here's my c. And if I go a little bit further, I'm going to have my vertex right here. And that's, so when you have a parabola, you have your vertex. And your vertex is up here. And your vertex is found in vertex form. Now, that's either PQ or HK, depending on your textbook. And your P, so your P and your Q, it goes like this, PQ, I'll use PQ. There's my P, that's how far I move side to side. And that is my axis of symmetry. My axis of symmetry is the line x equals P. And I also add something here also. So if is my vertex, I should have made this a little further, but there's my vertex. I also have here my Q. And my Q is the maximum value that I get on my parabola. So when I have a parabola that opens down, like this one, the green one and this purple one, I'm going to have an axis of symmetry, and I'm going to have a maximum value. And the maximum value is my Q or my K, depending on which version I use. Okay, so that's my maximum value. If my parabola opens upwards, then it goes down to a minimum value of of Q or K. And then it comes back up. So these guys have max values, and these guys have min values. All right, so a minimum value. And when does the minimum value take place? It takes place, what we say is it takes place at when x equals p or h. Okay. Now, the whole thing I'm looking at here is here are my three different forms, factored form, standard form, and vertex form. How do you go from one to the next? These two guys here, how do you go from standard to factored? You factor. Okay, so you factor to go this way. You expand to go the other way. And if I had vertex form, you open up these brackets here, you square this and multiply by a and add q, and you expand here. Now, you never go from vertex to factored straight, but you can always go from one to the other if you go through standard. Now, there's one thing missing here, one arrow here missing, and that is, oh, I messed this up. That's this part here. So you go from vertex to standard by expanding, but how do you go from standard to vertex? How do you find the vertex from here? How do you go from this version to this version? And we have not done that, or you have not done much of that, unless you got a little bit ahead last year and you completed the square. So completing the square is how you go from standard to vertex. You get, you could probably imagine why you want to get the maximum value. How high does something go in the air if it's shot? When does it get to that maximum height? So for whatever reason, if that's your question that you're asking yourself, you need the vertex. Okay, so that's that. That's sorry, what's going on here? That is why we're doing this. We're completing the square to do that. Sorry. So let's complete the square. So right here, I have completed the square, and it's an algorithm. It's a bunch of different steps, and I've done all the work here. Here's your equation, and this guy here is in standard form. And we're going to go all the way from standard form, and if you notice, we're going to go from standard form to vertex form. Oh, what have I done here? To vertex form. Okay, so you go from standard form to vertex form, and you have to do a bunch of different steps. So they're all in front of you, and I thought I'd write them out and describe them for you. So the one thing that you want to do for sure is, this is C, right? This is your last term. This has nothing to do, so see my negative or my plus 5 here? This guy here, what you want to do is have nothing to do with anything until the very end. So remember, see, sometimes what I do is I don't even write it here. I write it way over here, so it's out of the way. Okay, so the plus 5, the plus 5, the plus 5, the plus 5, you don't touch that until the very end. So that's one thing to remember. Okay, so we do a bunch of steps. We get rid of this 5. And the first thing we're going to do is factor out anything or common factor, anything that's in front of the first term. So I want to common factor the first term. but I don't want to take the x out. That's partial factoring, which is tomorrow's work. So take out a, divide by a. So I have 2x squared minus 8x. I divide by a, so I'm left with x squared minus 4x inside the brackets. Okay, so I divide this by 2, I divide this by 2, and I have a 2 here. Now we got a bunch of work to do. So draw your big square brackets here. People tend to like that. And then what you do is I take this number here and I divide it by 2 and I add it, I square it and I add it and I square it and I subtract it. And the question is, why would you do that? And the answer is because it gets me to where I want to go. You would never do this otherwise. There's no reason to do this, to square something, divide something by 2 and square it, unless there was a reason to get somewhere. And the place you want to get to is vertex form. Now, can you do that? Yes, you can. And let me just prove to you why you can do that. Here, let me just move this guy out of the way. It's driving me nuts. So here, if I had something, if I had 8, if I said 8 is equal to 8. I was going to do 10 subtract 2, but 8 is equal to 8. Okay, that's very deep. 8 is equal to 8. Are you with me on that? Yes, good. Okay, then I'm going to say 8 is equal to plus half of this squared, 4 squared, subtract 4 squared. Is that equal to 8 also? Sure it is. That's 8 plus 16 minus 16. So this all cancels itself out. What you're adding and subtracting is the same thing. So you can do that all day long. You wouldn't do it normally because it's just a waste of time, but you would do it in this case because it gets you to where you want to go. Okay, so you take, let's go over that again. You take this number here, you square it, so it's minus 4. You divide it in 2 and you square it. You add it and you subtract it. Now we're going to do some little things with this. And one thing we're going to look at here is that this here, x squared minus 4x plus minus 2 all squared is, in fact, x minus 2 all squared. So if you were to expand x minus 2 all squared, you would end up with this entire thing here. Okay, and if you expanded this minus 2, you would get plus 4, and if you expanded this entirely, you get plus 4. Why don't we expand it here? Because there's no reason to do it. We're going to go back to this version right here eventually. Okay, so step 1, get rid of the 5. Step 2, get the a out. Step 3, add and subtract this guy divided by 2 all squared. So cut this in half and square it. So I got x minus 2 all squared. Okay, then what you do is these first 3 terms here turn into bracket x something, and the something is whatever's right here. This minus 2 goes right there. So x minus 2 all squared. What happens over here? Well, I got to square this one here because this isn't part of what's in the root here, or sorry, in the bracket here. So I need to take this minus 2 and square it, and when I do that, I get 4. Okay, so that's the next step. So this is all taken care of. It's almost cleaned up. I have a square bracket I need to get rid of. So to get rid of the square bracket, I open it up and I multiply everything in the bracket by everything outside the bracket. And when I do that, I get 2 times what's in the bracket here and 2 times negative 4, which is negative 8. The last step is to deal with the 5. I have negative 8 and plus 5. I deal with that and I get minus 3. Okay, so a bunch of steps, no common sense at all. You would never do any of this ever unless you knew to do it. But that's the way you go from standard form to vertex form. So now I got vertex form. And my vertex here is plus 2. Remember, change the sign. Minus 3. So what's that? Let's see if we can take a look at this here. The red graph here is our 2x squared minus 8x plus 5. And now I had a vertex of 2 minus 3. And if I go here, you'll see that my vertex is 2 minus 3. Some other things we want to look at here is how we discuss this. Okay, so this guy means 2 minus 3. We're going to talk in the terms of max and min. This is a min. As low as this goes is minus 3. And it happens when x is equal to 2. So when do I get to minus 3? Oh, I get to minus 3 when x is 2. That's when I get to my min. Okay, so a lot of times the question is, what's the max, what's the min, and when does it take place? So you would say you have a min, and it's a min because it opens up, right? And we know it opens up because a is positive. A min of negative 3 at x equals plus 2 or just 2. Okay, that was a bit confusing. This is more confusing. Okay, not that, that's easy. This, now, where it gets confusing is when I have an a value that is a fraction. Because if you remember or not, clean that up a bit. If you remember, dividing by a fraction is going to cause a bit of a problem for some people. So I have 1/2 x squared minus 3x plus 1. first step, again, get rid of this one, jam it over here. Okay, you're not playing with us. And step 2 is to divide out a, factor out a. And when you do that, you divide by a, you put a half in front of this whole thing, and you're going to divide x squared, or 1/2 x squared by a half, and you just get rid of it. And then you're going to say -3 has to be divided by a half. And a lot of you are going to say that's 3/2. That's not 3/2. Okay, -3, or not -3/2 either. -3 times a half is equal to 3/2. -3 divided by a half. So if I come down here, if you remember fractions, when you divide by a fraction, you multiply it by its reciprocal, or its inverse. So 3/1, 3 divided by a half is the same as 3/1 divided by 1/2, right? Just writing them both as fractions, which is the same as 3/1 times 2/1. So remember, you flip this guy upside down when you divide. So that turns into 6. So when you divide a number by a fraction, it may not go the way you think in your head. Once you get to this point, though, everything else is the same. I take this guy here, -6. I divide by 2 and I square it. I add that and I subtract it. I then clean up the first 3 terms here. So these 3 terms here are a perfect square, and we'll go over perfect squares in class, why this makes sense. And it turns into x -3 all squared. That -3 is the same as this -3. Then I have to square this guy over here. So -3 squared is +9, but I want the negative of that, so that becomes -9. Then I have my square bracket I have to deal with. Get rid of the square bracket, put the half in front of this, and then multiply the half times -9. So again, play around with fractions. And do you need to use fractions? The answer is yes, you do. You can do questions with decimals, but when I ask you to use fractions, you're going to have to use fractions on quizzes and tests. So -9 times a half. So now we have -9 times a half. Okay, and that's the same as -9/1 times a half. 9 times 1 is 9. 1 times 2 is 2, and you end up with the -9/2. Okay, plus 1. Then you have to add 9/2 plus 1. You get -7/2. So a little bit of grade 6 math there, combined with some grade 11 math. A lot of fun. People love fractions. And that's my vertex, or that's your vertex. 3 -7/2. Okay, and what's that mean? Well, let's think about that. That means my vertex, let's go to our Desmos. Desmos, I hope you're using them. They're great. This is over here in green. So I'm up here, and my max, you can't see that. I can't see that. But if I could see it, I would know. Oh, there we go. That I have a -3 and 5.5 is my vertex. Okay, and what did I do wrong? So I figured I wouldn't have it. I put a negative in front of this whole thing. So let's get rid of this negative. So when I look here, I have 3 -3/2 as my vertex. This green guy, let me get rid of the old red one here. So 3 -3/2 is my vertex. And going back to here, I have 3 and -7/2. And if -7/2 is, in fact, -3.5, right? So when you graph that, it's fine to use a decimal, but just when we're playing around with the steps, I need you to use fractions. So what happens here is that's my vertex, 3 -3.5. So I have a minimum, again, so this guy here, again, opens this way. And I have a minimum of 3.5. So I go down to 3.5. That's as low as I can go. I can't go any farther. And it takes place at 3. So when x is 3, my minimum is 3.5. So if you were to write that out, you just write there's a min of -7/2 or -3.5, either way, and it at x equals 3, or takes place at x equals 3. Okay, hope that makes sense. A little difficult, a little confusing. Completing the square. Once you get used to it, though, if you do 2 or 3 or 4 of these, you will be laughing. Okay, partial factoring next. Take care.